Okay, class. We looked at how continental drift happens and the evidence for that, but Wegener ran into a problem, and his problem was he couldn't explain how the plates moved. Well, 50 years later, there was a gentleman, his name was Harry Hess. He was in the Navy in World War II, and he was traveling across the Atlantic Ocean. During that time, what he did was he took readings of the ocean depth as he went across the ocean. And what he found out was in the middle of the Atlantic Ocean was this ridge, kind of like a mountain range running along the entire north to south of the Atlantic Ocean in the middle of it. And so he proposed this idea that what was happening at the center of the Atlantic Ocean is that new material magma was rising up from the surface, splitting that ocean floor apart to make room for that new magma, thus pushing the seafloor apart. And if the seafloor is pushing apart, then the continents next to the seafloor are pushing apart. So he had this great idea for what was causing the continents to move. You're going to be taking these notes today. On the bottom of this page down here where it says seafloor evidence, fill in those blanks as we go along. And again, if I go too fast, hey, make sure you pause the video. So make sure that as you're looking at this, you're paying attention to the diagram below. So we're looking at the ridge in the center of the Atlantic Ocean. And we're going to be putting some more evidence on there. The problem is Harry Hess didn't have any evidence to support his idea other than the ridge existed. Fortunately for him, that evidence came the very next year with two other scientists who got on a ship called the Glomar Challenger with a drill rig on it, and they went across the Atlantic Ocean, and they took all these drill samples from the ocean floor as they went across. And they were able to get some evidence out of the rocks from the ocean floor to support this idea of seafloor spreading. So what did they find out? Well, they found the rocks that are closest to the ridge are the youngest rocks, which makes sense if magma is rising there and forming rocks right there. That should be the youngest. And then as they get split apart and they move farther away from the ridge, the rocks get older. The second thing was that in this diagram, you can see there's dark blue and light blue layers and a couple of layers that have the letter A on them. And these are basically showing you that in iron-rich rocks like basalt magma, they will the crystals will align themselves in the direction of magnetic north. And our magnetic poles have shifted over the time of the Earth from north to south and back again in an intermittent fashion. And that's preserved in these basalt rocks. And so what they found was that the magnetic direction matched on opposite sides of the ridge in the middle of the Atlantic Ocean, which means that these two sections A that matched, they had actually formed together at the ridge, and then every layer of magma that erupted in between there had pushed them apart. And they found that all those layers matched. So now we had an explanation for how plates move and evidence to support that was actually happening. So 50 years after Wegener came up with the idea, we finally had some evidence to show how plates move and supported that idea. And it really became mainstream in the geologic community. Now you're going to do a lab activity today, watching some videos of and analyzing some seafloor spreading evidence. Good luck.